guys, it's Sherman Gittens. I'm going to be doing a first order application problem, a mixing problem from the Veeh text, and we're going to be doing 5-9. I usually have problems with a lot of these mixing problems, so I figured I try one out, and if I do mess up, please let me know. These are usually tough for me to set up, so I'm going to go through this in a very systematic way. Please let me know if you have any tips for me or any ways that might make this go quicker or easier. Any feedback is appreciated. Thank you. So here we go. So fresh water enters a swimming pool at a rate of 500 gallons per hour. And water leaves through the pool drain at the same rate. So the pool can hold a total 5,000 gallons. Okay, so we know what the pool can do. So here's tricky part. A quarter-pound chlorine tablet, so that's important, I believe. Is placed in the pool will dissolve completely in 5 days. So a quarter pound takes 5 days to dissolve. Okay, and the question, the thing that wants us to find is how many quarter-pound tablets should be placed in the chlorine-free pool so that 2 pounds will dissolve in the pool at the end of 3 days. Okay, lots to unload there. So let's go with let's go with what we're given first. So see that we're given that it's a 500 gallon pool, 500 gallons per hour, and it leaves at 500 gallons per hour. So let's figure out, so it gives us a lot of other stuff in days here, so I want to make everything in the same denomination, so I'm going to try to go for the smaller of the two things. So I'm going to try to find days. So we have 500 gallons in 1 hour. In 1 hour. So what does that equal? So that, well, we're going to multiply that. Sorry. Get rid of that. So we're going to multiply that to try to get what this is in days. So we know that there is 24 hours in 1 day. So obviously hours cancel out. And that's going to give us 12,000 gallons in 1 day. That's how much is going in and out in 1 day. So that's our first given. Our next given is this chlorine tablet. What's the rate that that gets dissolved? So we know that that rate is 0.25 pounds, quarter of a pound, divided by 5 days. So every 5 days, 25 pound, quarter of a pound tablet will get dissolved. So we got that. So now we need to try to figure out what does that mean? How many pounds per day is that? So we're gonna just try to get it all into pounds per day, and the nearest whole number for that. So that's going to give us 1/20th. Because quarter is 1/4. So yeah. So that's 1 pound. No, pound per 20 days. Okay. So It looks a little cleaner right there. So we got that, and so now I think that it's a good starting point. So now what do we have to find? We have to find how many quarter-pound tablets should be placed in the chlorine-free pool so that 2 pounds is dissolved in 3 days. So we have all this information. So we need to find how many tablets. So we'll say the number of tablets. So number of tablets, and we'll call that, I don't know, A. A seems like a safe thing to call that. So, and I want to find the number of tablets so that 2 pounds dissolve in the pool in 3 days. So we need something to call for our number of tablets dissolved in the pool after a certain amount of days. So we'll use T as our certain amount of days for our time. It's called P for pounds, I guess. And just to avoid everything else, I want a C's for chlorine because it'll get me confused with the constants. So P of T. So, and then we want this to be so that P equals, gosh, what was it? We want 2 pounds, so 2 pounds when time equals 3 days. This line right here just means when, so it's a little shorthand. So now I just want to state some assumptions that we're going to have too. So obviously, with saying all this, we're assuming that the tablets dissolve at a constant rate, and we're also assuming that everything is instantly mixed. So with those assumptions now made, now we can just get to the problem. Set this up. So some analysis. So now P of T can be represented as dP dt. And so we need the number of tablets. And then we know that it dissolves at a rate of 1 pound per 20 days. So that's 1 over 20 right over here. And then subtract that from how much is going to be dissolved in the pool. And so we know that we have this much going in and out at any one time. And we know that we have 50,000 gallons. So when you multiply those together, well, you don't multiply them together, but put them in a ratio here. So you got your 12,000 top, 50,000 on the bottom. Times the amount that's in the pool at that point in time. So now the real fun begins. going to clean up what's inside of here, and then we're going to bring it over, and then we're going to do an integrating factor, and we're going to have all that fun. So let's get started. So this inside of here can be simplified as 6 over 25. So, and then we bring it over. So now we have dp dt plus 6 over 25 p equals a over 20. Just simplify it. It's just easier this way, I think. Okay. So now we got to do our integrating factor. So let's do it over here. So this right here, well, I guess p was a poor choice because this is our p. So 6 over 25. And then it's dt. So that will get us a EO625 t. So that's our integrating factor. We're going to put it in here, here, and here. And then when we derive this side right here, and we do dt, I'm not writing it all out because my handwriting is just poor with this program. So please forgive me for not writing it all out, but please understand that this integrating factor, so let's put this as IF, and then we'll say that the IF is here. And then here as well. And then we integrate both sides, dt. So this side, again, this is just a little shortcut, but we know that it's going to come out to be 6 over 25 t. Bring that p over here equals. So this side, so I'm gonna, there's not a t in this, so we get a little lucky bringing all this stuff out, and then we have the integrating factor over here that's got t. So what we do is we'll multiply what's in the integrating factor up here, multiply the bottom, and then divide by the top, and we come out with 5a or 24 plus, oh, not plus yet, but times e to the 6 over 25 t plus that magical constant. So now we're going to divide everything out by the e to the 6t. Divide 6, 6 to the 25t. Divide this all by that as well. And what that gets us, something that looks a lot nicer, p equals 5a over 24 plus c e to the negative 6 over 25 t. So from there, we are going to try to find this constant. So we're going to make another assumption here that P at time equals 0, the amount of chlorine that's in the water at time equals 0 is 0. Now, you tell me if that's something we can't assume, but I think that's a safe assumption. So from there, we find that we have 0 equals 5a 24 plus, now this all goes to 1 because e to the 0 is 1, plus c. So c comes out looking like negative 5a over 24. So now that we have that taken care of, if our solution looks a lot better, so now we can plug some numbers in here and get our a and find our answer. So I'm gonna write this all out, and I'm gonna show you what I actually think is gonna look cleaner after just seeing this real quick. So e to the negative 6/25t. So now we have 5a over 24 on both sides. So what I'm gonna do with that is I'm just gonna make it a little cleaner. Equals 5a over 24. So it's 1 minus e to the negative 6/25t. Parentheses. So let's go from there. So we have what we want to look for, right? We want to know, say P is 2 pounds. So we want there to be 2 pounds in the water, and at 3 days. We have everything in days, so the time should be fine for that. So 2, that's 5a over 24. 1 minus e, and then I'm just going to put parentheses here because we're going to get a little heavy up here. So and we're going to multiply that by t, which is going to be 3 days. So I'm just going to do the math out real quick without writing it all down. This whole thing in here, so 1 minus whatever that's going to come out of this. So what's going to come out of this is a decimal. So we're going to expect a decimal to be in there afterwards. So we have 2 equals 5a over 24 times, and 1 minus e to this, so e to the negative 18 over 25 is going to be 0.51325. So guess what? We're going to divide that over here. And let me write that out. So we got 2 divided by 0. Divided from both sides, obviously, but so this side that gets affected a little bit more equals 5a over 24. So what we get over here on the left side is 3.89675. I brought out a lot of decimals because they're going to slowly disappear as we go on. So I'm going to multiply it by 24 on both sides. And then divide by 5. And what that's going to get us is a. And so when we do all that, so a equals 18.7. I know there's a lot more decimal points after that, but really we can't have, we're not going to have a half a tablet or zero point 0.7 of a tablet, so we're going to say that that comes out to A equals 19 tablets. Make sure we let them know that's quarter pound tablets. So that's the answer I got. Like I said, if you see that there's a different way or an easier way or a better way to do that problem, let me know. Um, and if you get a different answer than me, please let me know. And if you do, give me a shout out on where I went wrong. But other than that, good luck with everything. I look forward to everyone else's videos, and I hope everyone does well on the test. Have a good one.